Here we go, day 16. So far, it's been a pretty fun season, I have to say. Let's see what our new problem is. So this is related to the origin of distress signal, yet another handheld device. However, you don't see any elves around. Surrounded by elephants. Okay, the ground rebels again much stronger. What kind of cave is this? You scan the cave with the handles, reports mostly igneous. This is it's a volcano. Device estimates you have 30 minutes before the volcano erupts. Scanning key further options to discover a network of pipes and pressure release valves. You aren't sure how much of a system such a system got into a volcano. Each of the valves' flow rates, if it were opened, and the tunnels you could use to move between the valves. Okay. Yep. There's even a valve in the room you and the elephants are currently standing in, labeled AA. You estimate it will take you 1 minute to open a single valve and 1 minute to follow any tunnel. What is the most pressure you could release? Okay, all the valves begin closed. You start at valve AA, but it must be damaged or jammed as the flow rate is 0, so there's no point in opening it. However, you could spend 1 minute moving to valve BB and another minute opening it. Doing so would release pressure during the remaining 28 minutes. Okay, so this is going to be a spread out and figure out what the best possibilities are. Let's look at our real puzzle input. Doesn't look too crazy, but there might be an exponential growth kind of a problem that we have to worry about. So given 30 minutes, 1651 following this. Okay. Sure. So the first thing we need to do is we need a regex for this. Regex is a new regex valve. Let's see, A through Z times 2. A through Z, A through Z. I forget exactly what that syntax is. And I go look at my real data. Again, everybody is a letter. They're all 2. They're all uppercase. That's fine. Okay. Has flow rate equal to digit plus. Tunnels lead to valves. And then this is going to be the rest of the line. Fair enough. Okay. Yeah, you're telling me I don't have a closed parenthesis. Okay. So we'll put this stuff in a class, right? Long flow rate. And then we need a relationship to its neighbors, which will be string array neighbors. So one of the things we're going to have to do here, obviously, is make sure we don't ever backtrack. Actually, we don't see any backtracking here. Oh yeah, we do see backtracking. Backtracking is okay, but we need to know whether the valve is opened or not. So backtracking is okay. Backtracking is okay. And we'll get bound by the fact that we have a maximum of 30 minutes in which to operate. Yeah. Interesting. Okay. So we need to parse this. So we're going to do select regex match against line. Let's do this. All right, var let match is this. And we're going to do select a new valve with match, let's see, match groups one value. That's already what we want for the name, right? So we need the name as well, or the ID. That's what we'll call it, is the ID. The ID, and we need the flow rate. So a long parse of match groups one, two value. And then we need this, which is going to be, let's see, so this is going to be match groups three value split on commas. Select the trim of that. All right, to array. All right, so data is now going to be an array of valves, right? Okay. Valves. Let's see, valves. It's going to be data. Let's see. Let's do data.toDictionary. Right. So what we want here is a key selector and an element selector. So this is going to be ID. And then it's going to be the actual valve, right? So this will be valve, not D. So we need this to be property, sure. Flow rate and neighbors. All right, that's all good. So this is ID with a big I. So those are our valves. So the minute, we're going to start with 1. Right, and we'll say, well, minute is less than or equal to 30. All right, this is obviously a 4, which I don't know why I always do this. A minute is 1. All right, so for each minute, we need to decide what we're going to do in terms of if we should open the valve. So we need to know the opened valves too. All right, so var opened valves. It's going to be a hash set of string. If not opened valves contains, let's see, we need our current position. Our current position is AA. So we're going to do current valve is valves of the current position. Valves. So what we want to do is we want to evaluate every possibility, right? We want to spread out and evaluate every possibility. So Okay. No valves are open, no valves are open, DD is open, 20 pressure, so current pressure, 0. I think what we want to do is we're going to need this to be, I think my first inclination is to have this be recursive. Right? On get optimum. So we want to get the optimum. I need to know what are the opened valves already, and your current position, which I guess we could just get with a valve, right? So valve, current valve, and current pressure. And we need to know what minute it is. That's an int, not a string. All right, so let's just do this. We'll say return get optimum for an empty hash set. The current valve is going to be valves of AA. The current pressure is going to be 0, and the current minute is going to be 1. Okay. So we don't need any of that either. Actually, don't need any of that. Okay. So the first thing is if minute is 31, then we need to return the current pressure, right? Because that's our exit condition for the recursion. Current valve ID. So one possibility would be to, let's see, possibility is going to be to get the optimum for the existing opened valves, the existing current valve, but the current pressure plus, actually we need new opened valves, right? New opened valves, be a new hash set. And actually, we can modify it in place. Current valve ID, current pressure plus the current valve's flow rate. So this is our opened valves, right? And then the minute plus 1. Var best right now is current pressure. So if possibility is greater than best, then best is the possibility. So that's open the current valve. And the other thing is to just visit all the neighbors. And also here we're going to remove ourselves from the opened valves because that's a temporary thing, right? Open our valve, visit everybody, close our valve, and then try visiting everybody without opening our valve. And then we'll say for each var neighbor in, let's see, current valve dot neighbors. We're going to do this again. We're going to say the possibility is get the optimum with the current valves with valves for the neighbor, right? And then pressure is not going to change, but the minute goes up by 1. And then we do this again. Return best. Let's see what happens here. Throw, overflow, or format exception in 64 parse. All right, we got a parsing problem on line 16. All right, so this should be, this is group 1, this is group 2, this is group 3. So what's the problem? It didn't actually say what the value was, right? No, it did. Empty string is not in a correct format. All right, something wrong here. Valve A through Z has flow rate equals blah. Tunnels lead to valve. Oh, valve and not valves. Okay. Still not. Okay. I don't understand. It's like we have a bad match, right? Match, let's see. For each x in all of that, console right line x. So we'll just select this. What was that? I just wanted to, remove that. What's going on here? Okay, what's wrong with line H? Valve HH has flow. Rate equals 22. Tunnel leads to valve GG. Oh, tunnel leads to valve. Tunnel leads. There we go. All right. This is taking a long time, which unfortunately is kind of what I expected, right? So I don't need you anymore. Minute is 31. Return the current pressure. Let's try 3 minutes and see how fast we get through it. All right, we get through it pretty fast in 3 minutes. Let's see. Uh, hmm. Okay, with roll tunnels, you could have probably opened many or all the valves by the time. However, you need to release as much pressure as possible, so you'll need to be methodical. Hmm. I'm kind of curious, how many of these am I computing? A lot, obviously. A lot. A lot, a lot, a lot. That's not great. Let's see. That's obviously not the right way, huh? How often do we repeat a path? So we go from A to D, we open D, we go to C, we go to C, we go to B, we open B. Let's see what happens here. Let's see if we see if I can print something out that will be very helpful, right? Which is progress. You're going to start with no progress. You're going to start with progress of AA, right? So here, what we're going to do is we're going to say progress plus open. Okay, and then we're going to say progress plus neighbor. So we'll do this. Progress plus neighbor, right? And here we're going to console right line best, right? Best progress. Isn't that interesting? Let's try 5 as our exit point. Yeah, that seems right. Oh, this is wrong anyway. Or is it? No, actually that's okay. This is where we want to print this, I think. AA to DD to open to CC to open gives us 22. Which sounds right. So 20, 33. But we know we go no open. That's weird. YouTube is yelling at me and saying there's no audio. I don't know if that's true or not. Well, not much I can do about it now. Hopefully you can hear me. Let's see. So we know we go from AA to DD to open to CC to open. You got audio, you're good, thanks. AA, DD open, CC open is 22. It's 22. How's that 22? AA to DD to open to CC to open. Oh, we don't stop here, that's why. But still, that's a lot of paths. All right, that's a lot of paths. There's got to be an optimization here about only picking the optimal path and ignoring the paths you've already taken. This is kind of like it's like a regular pathfinding algorithm, except you're not really trying to get from A to B. The problem is you don't know where you're going to end up. So like a normal pathfinding algorithm would basically trace your steps backwards and only take the most optimal route of every step backwards. Yeah, the problem with, I'm thinking about this, like the problem with trying to guess about not repeating ourselves is we definitely have to be able to repeat ourselves, right? So it's not like I can cache this and say, hey, if you're at AA, this is what it is, because that's normally what you do at a pathfinding algorithm, right? Because you're just still trying to find the optimum version. Hmm. My guess is if I bump this back up to 31, right, we're just going to get tons of output. But the problem is we're considering a lot of options here. Yeah, we're just not we're not going to converge fast enough. Yeah. How do we converge faster? Hmm. Let's see. I wonder if the answer is sorting by flow rates and trying to find the fastest path to the highest flow rates. The problem is, like, if I look at H, for example, having the flow rate of 22, right? It's not directly connected to A. And if I just follow a path to H to get it open, then it's going to end up maybe just wasting time just trying to get to that 122. Hmm. The solution they found, let's sort of look around here and see if I can sort of determine what an optimal solution might look like based on what their proposed solution is here, right? So we start with nothing open, right? We're in AA, we have no flow rate. So we start with nothing open. We can go to DDIIBB. So do we prioritize DD because of its flow rate? Right? And then it is interesting. So we end up opening up DD, BB, JJ. So DD, BB, JJ, HH, EE, this approach lets you release the most pressure possible in 30 minutes with this valve layout, 1651. Oh, I also don't even really know what it is we're trying to solve here. All the valves begin closed. Oh, I see. We're releasing more pressure as we go. Sure. All right. Doing so would release the pressure during the remaining 28 minutes. So the pressure here is going to be 30 minus, what do we call it? Minute times this. I mean, I still don't think this is going to solve it fast enough. Come on. Come on. Right? We're still just sitting here forever. You definitely want to try and prioritize the fastest, the biggest things soonest. It is interesting that we notice here that like there's a bunch of minutes where you're not even moving because all the openable valves are open, right? 1, 2, 3, 4, 5, 6. All the openable valves are open. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's certainly a possibility to cut us down. I don't think that's going to cut us down enough though, right? Openable valve count is valves where the valve, come on. Clearly, valves values where the flow rate is greater than 0, count. Or openable valve count is equal to opened valves count. Opened valves count. I don't think that's going to cut us down enough. Yeah, that didn't help us cut down. How are we going to cut down this problem space? We could cut down the problem space by actively trying to get to each valve that has a value in reverse order. Well, actually, it doesn't even really matter what order it's in, right? Just in an order, try and get to every openable valve. What would that look like? So I like this. I think I'm okay with that. Openable valves. Hash set. What if we do it like this instead? Instead of opened valves, we do openable valves, right? And then what we'll do is the openable valves will be valves where V value flow rate is greater than 0 to a hash set with a selector that looks like V, come on, V, ID. I know 2hash set has to be able to do this, right? This is the source. Okay. Then I guess we don't do it like that. We do a select and then a 2hash set. Key to hash set. So if those are the openable valves, then what we need is openable valves count is 0. We don't need that at the moment. So this will be openable valves. And then this will be openable valves. You'll get removed and then added back. Right, openable valves. So we may want to open ourselves. Then we want to basically openable valve in we're going to put you there, and you can go back there. So for each openable valve and openable valves, so we don't want to include ourselves in the list, right? Valves ID, valves ID, order by descending, valve flow rate. Actually, I don't even know that I need to. I don't even know that order is even important here, right? We just want to try and find the fastest path. Right, we want to find the fastest path to each one of these. That is something we can pre-compute. Yeah, that is something we could pre-compute. Paths are going to be valves select. We want to know, given a valve, for each of its neighbors, let's see. Actually, we don't even need to know that. What we need to know is for a given path, how many minutes would it take to get there? We don't even need to know the path, right? We just need to know what is the quickest time we can spend getting there. Let's see. let's do this. Let's do path cost cache. You're going to be a dictionary of string to long, right? Or int is fine. And then we'll do int get path cost string from string to. Best is going to be int max value. We know right. Valves from neighbors. Let's do this. We'll say if val, let's see, from is val, whoops, from valve is valves from, to valve is valves to. If from valve neighbors contains to, then let's see. Well, first up, if post path cost cache try get value from and to out var results return results. It's out var best return best. And otherwise, best is going to be max value to start with. We'll say var, yeah, no, that's right. So for every neighbor that's in my from valve neighbors, I actually don't care about that. I'm going to say possibility is get the path cost of the neighbor to 2. Hash set string visited. And then we remove that. We had ourselves in there. Possibility is less than best, and best is possibility. And then here we say the path cost cache of from and to is best, and then we return, whoops, leave that, and then we return best. Okay, so for every openable valve, we're going to try and see path cost is going to be the get path cost for our current valve ID and the openable valve ID. Openable valve, right? Or those strings. Like I said, those are already strings, right? So that's the path cost. Visited can be null by default. That's fine. If path cost, let's see. So we need minutes left, right? I think. Actually, just getting there doesn't help. So if the path cost is less than, actually, yeah, it's less than the minutes left, then we could say another possibility then would be to get the optimum for openable valves, which still doesn't include this one, but it will when we get down through here, right? The current valve would be valves of the neighbor, of the openable valve, sorry, of the openable valve. We don't get any new pressure by going there. We have minute plus path cost, right? And then can't really record progress here. This whole progress thing's just got to go away, which is fine. If possibility greater than best, then best is the possibility. And then we put that back. Is that actually going to work? I guess we could do a console write line of current pressure. Stack Overflow, get the path cost is Stack Overflowing. Okay. Let's do this. If, we probably forgot to do this. If from is equal to 2, then return 0. Is that part of the problem? Nope, that's not part of the problem. All right, well, let's see what's going on here with the path cost computation. Okay, so we're going to go from, where's my locals? We're going to go from AA to BB because BB is obviously an openable valve, right? Is obviously an openable valve. So we should be able to go directly from AA to BB. Okay, so not a problem. So best is int. We don't have a visited list yet, so we'll make one. We'll add us. The from valve is AA. The neighbor is DD. I thought I had a special case for this. If from valve neighbors contain, man, I could swear that I wrote this. Maybe I just deleted it. Right. Then best is 1. Otherwise, we'll do this thing where we get the path cost to each of the neighbors on our way there. Still. All right, let's see what's going on now. So AA to BB should bail out of our easy situation. So best is 1. So from AA to BB is 1. Visited. Actually, we don't have to remove anything from visited because, oh, we do because it's a shared hash set. That's fine. So our best there is 1. So now we've got BB to CC. So BB directly leads to CC, so that gets out of there fast. So we have both of those in there. Okay. Now we're going to go from CC to DD, which has a direct path. So it's also 1. We're going from DD to EE. And that has a direct path as well. Okay, and now we're going from EE to HH, which does not have a direct path. Okay, so visited right now. Why is visited? Oh, that's okay. EE to HH, that's fine, it's empty. Okay, so the neighbors are going to be FF. So EE to FF to HH. So I see we got to go, we're going backwards. We never checked to make sure we haven't been already visited, right? That's why we're looping. If not visited contains the neighbor. So if we haven't already been there, then we can do this, right? Let's just do this. Collections modified enumeration may not proceed. Get optimum 73. Get optimum 73. And the openable valves. Okay. Openable valves definitely got modified because we passed it through here, right? So we'll take a copy of it. And we end up with 0, which is not where we wanted to be. All right, so what's going on with get optimum? Okay. So the current valve should be AA, right? It is. We're on minute number 1, and the pressure is 0, and we have 6 openable valves. Okay. So the best is the current pressure, so that's 0. We remove ourselves, which, oh, yeah, we're going to add ourselves back into openable valves, even if we weren't in there to begin with. But that only should be done here. That is originally where I had it, and then I moved it out, and I don't remember why, but is that going to help? Well, it's a bunch of 1780s. A bunch of 1780s. We know that 1651 is supposed to be how we got there. Fine, we'll keep the path again. Type of namespace distance. From and to. So best is going to be int max value. Best is going to be null, I guess. Out. Cached. This is going to be a default of int and string. Okay, so if best is equal to null, or the possibility sorry, path cost, get the path cost. This needs to be int distance string path, right? Return cached. Okay, that's fine. So that is going to be excuse me, 0 and an empty string. Okay, so best or the possibility distance is less than the best distance. All right, so this is default int distance string path. All right, you're killing me, Smalls. Okay. Doesn't contain a definition for distance. Sure it does. Sure it does. So this is going to be 1 and just from. That's my entire path. From value contains neighbors 2. Oh no, that's not true. It's going to be from. Oh no, we'll just do 2. Because what we're going to do is we're going to return. We're not going to return exactly best. We're going to return best distance, best value distance, and then this, which is from, and then this, which is, let's see, now we're going to do the result. Our result is this, from, and then best path, best value path, right? If best is null, throw new invalid operation, because there should be no way to not get to somewhere. So that's the result. The post cache gets the result. Visited, removed, from, return the result. So now this is going to return path. So then this is going to be string path. You're going to start out empty. Now you're going to start out AA, because that's where you are, right? So the best is current pressure. And the best path is the path. Here we're going to say this is this. We're going to say best path is path to best dot get optimum best dot path. So optimum no, actually that's not a problem, is it? I don't think I need this. What I need is this here. This would be path to open, right? And then the path cost here, so the path cost dot distance, this is a minute plus path cost distance. And then also this is going to be path, and then this is going to be path cost path. And here we're going to right line current pressure path. So we've got that again. Let's see if we can figure out what's going on here. Operation is not valid. So we got path cost. We got something that couldn't be found. Isn't that interesting? What couldn't be found? Could not find path from to. Really don't understand that one. Can't find a path from JJ to HH. JJ leads to II. II leads to AA. AA absolutely can eventually get to HH. II leads to AA. AA gets to HH by way of GG. We get to GG by way of FF. We get to FF by way of EE. All right, I don't understand that. So JJ to HH. So JJ to HH. So let's set a breakpoint. Let's set a condition. Let's say from is JJ and to is HH. All right, now let's debug this. Let's find out what's going on here. We don't need U for the moment. So here we have JJ to HH. What's in our path cost cache? A few things. So we're probably on our way. So we've done FF to HH. So we've gotten to JJ. We're going trying to go, I'm sorry, from JJ to HH. How did we get to JJ? We have this, which is JJHH. We have this, which would be II to HH. I didn't mean to kill that debugger. So JJ to HH. JJ is going to lead back to II, right? Because JJ can't go directly to HH. We're not in a cache. Let's do this. I'd like to get this recorded as well, which is best is going to be equal to that. Otherwise, we do all of this. Just because I'd like to record all that in the cache, right? Okay. So what does our cache look like now? So why is that a cost of 1? FF to GG to HH? That shouldn't be a cost of 1. That should be a cost. That should be a bigger cost than 1. So you need to be 1 plus this. Here, get a path cost to our neighbor. If best is null or possibility distance is less than or no, this plus 1 goes here. No. Right. Possibility distance plus 1. Possibility path. That's weird though. Yeah, okay. It's fine. Okay, so what does our cache look like right now? So there's a 2. All right, so FF to GG to HH is 2. Okay, so we're trying to get JJ to HH, which is fine. So the only neighbor from JJ to is II, right? So we've already visited II. So this visited, that's weird. I think I have to move the visited updates up here. Because where else do I use visited? It's here. I'll find a path from JJ to HH. All right, let's do this again. So what does our visited look like? So we have II already, right? So we won't go from, okay, so given this, I think what this means is we're already on a path. Yeah, so the placement of the add and the remove was actually not a big deal. That was not a problem. We can move those back. So basically, we're going to make you return null, right? If best is null and possibility best is null, or possibility is not equal to null and this is true. No, we have to move, we have to hoist that one out. That check has to come out here. Come on. Possibility is not equal to null, then we have to do all this. 1, 2, 1, 2, what's the problem here? Oh, of course, now their value. No, that, yeah. Because those are structs, so nullable structs comes out like that. Yeah, so this is basically saying we've hit a loop. If you've hit a loop, you can't do anything here. Let's just run this. What is the problem? Path cost is equal to null. Throw new invalid operation. Could not get a path cost for. I don't think this should happen, but I would like to know why. If it does, current valve ID, comma openable to openable valve. Okay, let's see what happens now. It's another infinite loop. Nope. Yes, Stack Overflow. Why? Why? Also, this needs to be up here. And this needs to be here. And where's my visited ad? Where'd my visited ad go? Okay. I stumbled on the reason I've been understanding some of the advent and never thought I'd do the example first. I feel like you could check to see if it's only one on the movable list. I was so busy looking at the comment that I didn't see what was going on here. 1568, what is all this JJ? 1568, hey, BB open, BBCC open, blah, 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 open. And then we've got JJ open, JJ open. We just keep getting 1568 over and over again. So did my path cost, we're never getting out because of minutes. We should be getting out because of minutes, right? Or openable valves. So minutes are 21. And the pressure is 1568. Is that how many minutes we waited? 21? 1568? No, we got 1651 is better than 1568. So we're getting out because of openable valve count. Unopenable valves, current valve ID. Current valve is what? JJ, which has a flow rate of 21. So we tried to open JJ. The possibility was 1568. And the path is AA to AA. What is this to AA? Why would AA go to AA? Path needs to be empty by default? Weird. Sure, whatever. EB, open, BB. Yeah, we keep putting ourselves in a list even when we don't have to. Which means this is just this. I know it seems like a silly thing to be concerned with, but I'm kind of curious. Okay, so minute is 31, openable valves are none. The path is HH, GG, and what? How did we not start with AA? Hmm. Oh, I know why. Yeah, I know why. This shouldn't be like this. It should be this. And then this should still have been this. And then, do we have the correct? Okay, AABB open, CC open, DD open, EE open, HH open, JJ open. And that gives us 1568. That is not the path that they went down, right? Because they went AA to DD. So the next path, right? So we're definitely not getting out of here for the right reasons. Because, right, AABB open, CC open, DD open, EE open, HH open, JJ open. Actually, that's completely not possible. AA to BB is fine, open. BB to CC is fine, open. CC to DD is fine, and then open. CC or DD to EE, and then open is fine. EE can't go to HH without stepping through other things. All right, well, maybe I should have left this here. Is that actually going to help me figure out what the hell's wrong? Who knows? AA. BB open, and then from BB, we go to CC, we open. From CC, we go to DD open, DDE, E, FF, GG, HH open. And then from HH, we go to GG, FF, EE, DD, AA, II. Wow, you're really long. View to AA to II to JJ, and then open. So what if this returned long and string, which is distance and path? All right. So you're going to return current pressure. I guess that's pressure and path, right? Current pressure and path. Let's not console write line here. Your pressure. Yeah, I know. Your pressure. Possibility. So the best is the current pressure. The best is current pressure with the current path. So if possibility pressure is greater than best pressure, then best is possibility. Possibility, return best, and then here, bar. Console write line. Console write line, result path, return result pressure. See what happens here, right? Okay, where did we flip? Stack Overflow. Get a hash code for a value tuple? I don't understand. Get path cost. Get the path cost. Hash code for a tuple. We're in path cost. All right, let's see what's going on here. So right now our cache should be empty. It is. We're going from A to B, right? Yep. So the distance, so the best is null. Visited is null, so you get something for visited. We're going to add A. From is 2, then we've got nothing. Okay. So the from valve is going to be A. Neighbors contains that, so the path there is just 2. Okay. Visited now, empty. So best is not null, so we get a result, we put it in the cache. So AA to BB is 1. All right, I think I understand a little bit of what's screwing up the printing. So that's that. That. And I think it's here that I want that. Oh yeah, from. Okay, so our cache is empty now. A to B, we should have just A, B1. Oh, but we're missing our A. Okay, then here, this is from to. No, I get it now. I get it now. Okay, cache is empty. Cache now has that to be B. Path now has that to CC. Let's find the first time we hit this. Okay, we're going from EE to HH. The cache now has that in it. Okay, so from EE to HH, we have visited nothing yet. All right. So the neighbor is FF. So from FF to HH, we have a 1. How do we get from FF to HH with a 1? FF only goes to EE or GG. Oh, because the neighbor is going to be like GG. Yeah, GG to HH is 1. Yeah, that makes sense. Actually, let's put it right there. We have to go through the neighbor, right? I think that's why that's like that. Okay, there's our cache. GG to something to HH? No, see, that should have been FF to GG to HH. So I don't. Oh my God, this is just. Why? Watch post cost cache path cost cache. So there's our first instance of a loop. Oh shit, I should have left that there. All right. There are no openable valves left, right? After this. So if we remove ourselves, there are no openable valves. If we remove ourselves, there are no openable valves. Right? Openable valves, we should, in the case where there's no openable valves, we should get our current pressure and path back. So why is that an infinite loop? Right? So there's a bunch of paths. Okay. We have no openable valves. We're at 21 minutes and the current pressure is 1568. Current valve is JJ. Because we opened ourselves. Okay, so let's step back out of that. So that puts this possibility. That basically says our current best is 1358 because we haven't opened JJ yet. Right, so that new possibility is 1568, so that's better. And then we go back to the openable valves. Oh, we don't go back into the openable valves. We shouldn't. With that possibility, right? Well, yeah, we should. Because this path, these paths for all of our neighbors, we need to do the paths without us. Because we might not open our valve. Oh, yeah, we need to know. All right, I understand why. I understand why we've got the loop. We need to know if we were in here or not. But we do know that because you were in here, which means you get removed and we get added back in. Never mind. Damn, thought I had it. I've run out of music. Play some more music. Path cost. So for each openable valve, try and figure out what the path cost is for that valve. How about this? Do we actually agree that AA to BB and all that stuff is worth 1568? All right. 1568, that's what we think, right? Pressure is 1568. Let's make sure that we agree that that is the pressure. Okay. So if we start at minute 1, pressure 0, and position AA, right? We can't open our valves, so we're going to go to BB, which puts us at minute 2. Still pressure 0, now we're at BB. We have a flow rate of 13, we're going to open that. So on minute 3, we opened that. So we should have, let's make sure let's see. Spend 1 minute moving to BB and another minute opening it. Doing so would release pressure during 28 minutes at a flow rate of 13. So we're in minute 2. So this is actually probably 31 minus this. Or minutes start at 0. I'm okay with minutes starting at 0. And then minutes can start at 0. Let's get rid of all that. So we should have a little bit more consistent possibilities here with our printing. Path to open. So 1649 with this, 1649 with this, 1649. 1649 is slightly less than our target, 1649. 1649, where'd our notepad go? So we have 1649 with this. All right, so 2 minutes have passed and we're now at BB. So if we, no, 1 minute passes and we're now at, 1 minute has passed, we're now at BB. So if we open the valve, all right, so if we open a valve, that takes 1, so that means 2 minutes have passed. So then we have, where's our calculator? We have calculator here somewhere, right? We have 28 minutes times 13, 364. Okay, so that's after 2 minutes, so that's the open. Then we move to CC, so that means 3 minutes have passed. 3 minutes have passed. Okay, and then we're going to open it, which means that's going to take another minute. CC is a rate of 2. So we have 26 times 2. We get 52 left plus 364. That's 416. 416. I don't really want to go through all this by hand. Let's do 5 minutes. Forgot. We're still broken. 431 at AABB open CC open DD. 431. Is that where we were? We're at 416. That's like an extra 13 and an extra 2. Let's do double plus minute. Minute. So that's minute. No, that's wrong though, right? No, that's correct. $30 minus that. If we're at this minute, no, that can't be right. Wow, my head hurts. Oh, it's so late. We're going to start at 1 again. That means whatever action I'm taking right now. No, go back to 0. So the action I'm taking right now, that would be that, and that would be this. Right, and then this would be minute plus a path distance value, because if I'm going to take those number of steps, then that's how many it's going to take. Okay. All right, I know it's still broken. I'm still trying to figure this out. Got 416 going to DD. 416 going to DD. That's what we've got. Okay, I agree with that. Let's go back up to 30. So if the current pressure is 1568 with this, so we're back to 1568, which I guess was correct. 1568 with that. 1568 with that. All right, what's next? 1568. That's different, isn't it? 1568. Whoa, how is there just a space there? There really is just a space there, isn't it? Why? What is going on here? More spaces? More spaces? Path. We just keep adding spaces. So we're not opening again, but we are potentially trying to get to the path value. That means we're trying to go from a neighbor. Yeah, all right. I want this breakpoint to be set for this condition, which is this is equal to empty string. Yeah. That's fine. You can go away for the moment. So the openable valves includes JJ because where are we? We are currently on JJ. Feels like it shouldn't, because what we're trying to do is trying to get from JJ to JJ. Which I guess means what we should do here is this should return null. Couldn't get a path cost for JJ to JJ. Right, which is fine. We don't want to ever try and go to ourselves. if openable valve is equal to the current valve, is not equal to the current valve ID, then we need to do this. So now we're doing a lot of nothing. So here we had a console write line. Let's put a console write line up here again. Console write line, current pressure, path. So we've got some things we need to do here, which is you should never go directly back to where you came from. Right, we're just evaluating a ridiculous number of things that are not adding any value. Okay, so if we're gonna try and get the optimum, I need this to be spread out a little bit better. So you're gonna be 0, you're gonna be 0 long, you're gonna be valves of AA, and you're fine, whatever. So this will be, yeah, that's fine. So what I want to know is, where did I just come from? So we're going from DD to EE to DD to EE because we're never opening them. Which I think means we are openable is openable valves contains current valve ID. And then let's put this back down here and say if we're openable, then go back into the openable list. AA. How is that helpful? So we never hit this anymore? Debug. We never hit that. I really don't understand how that's possible. How's that possible? Okay, so we have basically no path. We are not openable. Locals. We're not openable. Okay. So we don't try and put ourselves into the mix. Minutes left, 31. No, minutes left should be 30. I think. I actually don't know if we actually need that, but okay. Do it again. Right. So the openable valves list looks like B, C, D, E, H, J. So the path cost from A to B is 1 BB. Path cost value distance is 1. It's less than minutes left. So that means we'll be on minute 1 just by moving. We'll have finished 1 minute, I should say. Right? Which means we are now on minute 1. We've finished 1 minute. Openable valves, B, C, D. Yep, so that's us. Right? So we're definitely openable. Oh, yeah. Okay, well, we skipped this, which is not good. Current valve flow rate greater than 0 does not matter. You can go there, that's fine. $16.51. And that's the path we followed. 1651, that's the path we followed. Okay, so the path looks like AA to DD to open, to CC to BB to open, to AA to II to JJ to open. All right, and then we go back to II, we go to AA, we go to DD, EE, FF, GG, HH. We open HH, we go to GG, FF, EE, we open EE, we go to DD, we go to CC, we open CC, and then we hang up. Oh my God. Question is, without all the console write lines, how fast is it? Instantly. Okay, great. That only took, how long have I been streaming? Where's my stream time? What the heck time is it? 22:57. All right, that took 2 hours. Doing good for so far for being late. I do not understand some of it, mainly what the blah does. Yeah. Oh, this is Lambda syntax in .NET. So this is our way of saying I'm writing a function that, given a parameter of v, which is a key value pair of string value, this is the function which is returning a bool, because that's what where wants. It wants you to give it a function that returns a bool. Anyway. Theoretically, that's it. Let's go get the real data. Let's go try the real data. Let's see if the real data will do its thing. We're still going to be way over on time. Oh, man. Yeah, this is a problem, isn't it? I assume I'm making progress. Let's throw some of our console write lines back in. So we are making some progress, but it's just like there's so many choices. Okay, well, I mean, I guess I'll let it run for a couple of minutes, see what happens. I'm gonna let this run. I'll be right back. I just need to take a quick bio break while this is running, and maybe we get an answer. And maybe if we come back and we don't have an answer, then clearly all this work has been for naught, and the solution isn't going to work. All right. Right. How do I kill these? Hide user in this. Let's put user in timeout. Hide user in this channel. Okay. All right. Now I will be back and we'll see what happens here. Sorry for the spam. Okay. It took a minute and 12 seconds. 2056. Let's go see if it's the right answer. 2056. Well, I feel like part 2 is really going to be problematic because if it takes an entire minute for part 1, then we've probably done it wrong. You read that even with an optimal approach, pressure release won't be enough. What if you've got one of the elephants to help you? It would take you 4 minutes to teach an elephant how to open the right valves in the right order, leaving you only 26 minutes to actually execute your plan. Would having 2 of you working together be better, even if it means having less time? Assume you teach the elephant before opening any valves yourself, giving you both the same full 26 minutes. $17.07. So basically I have to run 2 of these in parallel. Can you tell I don't want to do that? You can probably tell that I don't want to do that. How would I run 2 of these in parallel, but only have 26 minutes? How would I run 2 of these in parallel with only 26 minutes? Okay, well, dual, get optimum dual. All right, so if we have openable valves, we have current valve for me, valve, current valve for other. All right, the current pressure, what minute it is, and the path. Path for me, path for the other. So if I'm running this in parallel, oh man, I really don't know. At this point, I really don't know. Does this mean what I should do is run so one thought is if I run it once, right, with all the if I run it once with only 26 minutes and find the optimal value there, keep all the valves open that are open, and then run it again. Is that the answer? Is that the answer? So the interesting problem with this, with the openable valves here, is that yeah, see, that's not going to do it because we both need to be able to know what the optimal path is in the context of what the other one is doing. As you run, you could mark off all the valves as you check it. Yeah, you're not wrong. I mean, that is the right answer. The problem is if I just run it once and then run it again with all the valves that have already been used, that's not necessarily going to get the most optimal pressure release. Because all it's going to do is it's going to get one optimal pressure release as if I were working alone and then try and add more pressure release. But that doesn't necessarily mean that that is the most optimal way for the two of us to do it at the same time. Hmm. Yeah, I know. I mean, I think this idea of you have to always, like, you have to run it like I've been running it, except you have to now fork out, I think the problem is that makes the problem exponentially bigger because at any given step, if we've already done a specific set of things, then I need to basically run in parallel everything that could be done from there on out and see what the result is. Um, and I don't know how to contain that. And we already know that it took more than a minute to run that. And I feel like with the current algorithm I have, if I just try and brute force more, I'm going to end up in a bad place time-wise. Oh man. me. So this is number one, would be current pressure, would be path me, and then also path other, right? You can just return to current pressure. We never really needed to return to path anymore anyway. Best can be the current pressure. We are openable, let's see, which is current valve me. Other is openable valves contains current valve for the other, all right? This is the problem where splitting all the effort is quite challenging because it's like I need to, if we're gonna open ourselves, then we still need to do all the other possibilities for the other one, as opposed to if we're gonna move, for all the places that we potentially move, we have to do all the possibilities for everybody else as well. Man, this is just, I don't think this algorithm is gonna work like this. There's gotta be something I don't understand about how this algorithm is supposed to be written. And it's 11:15 p.m. for me. And I'm starting to feel like this is gonna be too much for tonight. Like I wanna sleep on this. Yeah. I think it's what I'm gonna end up doing. I'm just, I feel like this whole strategy isn't really gonna be good. Like I need to find a version of this that is much faster. And my gut feeling that this is still just fundamentally a pathfinding problem is still a possibility. How long does this take with this data right now? It takes, well, not, yeah, 0.23 seconds. It's just not super long version. But what would a backwards version of this algorithm look like? Backwards version of this algorithm, like a pathfinding algorithm, would be pick an openable valve, right? Because we know the very last thing we're going to do is open a valve. All right, so pick an openable valve. All right, let's start pseudocoding this here, right? So pick an openable valve, right? Open it. Problem is we don't know how much value it has. What is its value? If we don't know how long, if we don't know the time, right? So it's like we need to keep a sliding value for this thing. So if we start there, then that's it. And then you got to move backwards to the next one. The problem is you don't have an end. Yeah, this is the problem. Like in a pathfinding system, the reason going from the end works is one thing to also look for is path crossing. I don't know what that means. What is path crossing? Let's pop open a browser. What is path crossing? Given a string path where path I is in north, south, east, west, each representing moving one unit. Okay. On 2D plane, return true if the path crosses itself at any point. That is, if at any time you're at a location you've previously visited. Okay, so that's actually not a problem here. Well, I mean, I understand what you mean here now, but that's actually not a problem, right? We know that our solution that we use definitely goes back through point A. Like that has to be allowed. Right, because we did this down here. Right, when we run this, right, we start in AA and we hit AA again here and we hit it again here. Right, we definitely, oh, you're talking crossing with the other. Yeah, maybe. I mean, I'm still stuck on the idea that this algorithm, while it works, is still not optimal, right? Because with the real data, if it takes a minute and 10 seconds, and we explode that out exponentially, like the path crossing thing, I kind of get, but I think if we're keeping the list of all the visited possibilities, then it's you know, all the openable valves, then path crossing doesn't really become a problem. I think if I want to do this optimum in 2 parts, right? If I want to do this in 2 parts, part of the problem is at any given minute, I have to know what both of us are going to do. Right? One way to solve this is to say, you know, at a given minute, if I know what I'm going to do, then I can pretend that I've done that, but then ask the other one to figure out the rest of its path, right? But the problem is that figuring out that path, that's the thing that costs me a minute and 10 seconds, right? And so if I were to do it like that, then what you end up with is, you know, again, the exponential explosion. All right, well, I'm going to end the stream because I don't have an idea that doesn't sound like it's just going to explode. So I'm going to end the stream for the moment. And then, I don't know, sleep on it. Maybe something will come to me. Anyway, thanks for hanging out with me. Apologies, this is the second time so far that I haven't been able to finish on stream. It's kind of a bummer, but I'll give it some thought. Maybe I can come up with something. So yeah, all right. So second star or not, I will see you all tomorrow.